Hi everybody, welcome to State and Side Effects in React. My name is Ilke Boezeman, I'm a JavaScript developer and I work for Purple Scout, a software consultancy in Malmö, Sweden, and you can find me online at Godspeed Elbow. So I wanted for a while to do a presentation about the evolution of state management and websites. And a couple of weeks ago React released a new API to do state management and side effects called React Hooks. So I figured this is a good opportunity to combine the two. We'll start with a bit of history and then I'll work our way to the present and then talk about the future. If you have any questions, you can ask them in the comments. So most of you who listen to this are likely software developers, or you're an aspiring software developer. And if you are a software developer, then you probably work with state every day. So this should be an easy question, right? Think for yourself, like what is state? How does it manifest itself in our applications that we build? And how has this changed over time? When you build a piece of software, it is likely not isolated. And if it interacts with other things, it must have some internal representation of state to reason about these interactions. This is also true for user interfaces. When you interact with a UI, that UI changes state based on your input. So if no state means no UI, then what's the most simple user interface? Think for yourself, just a couple of seconds. It's of course the on-off button. To be able to interact with something, you need at least two states. One on or off, true or false, 1 or 0. It's a boolean. And you need to be able to change from one state to the other. You can describe state with a state machine. And I don't want to get all academic on you, but it is just an easy way to visualize what we're talking about. There are two states and two transitions between those two states. And this is actually not the most simple state machine. This is even simpler. And like I said, software is seldomly isolated. It interacts with other software. Most systems consist of many state machines that are connected. And you could also see the user as an agent, a system. And when you turn on as a user or turn off the light switch, you interact with that light switch. You change its state. So this is the definition of a side effect, changing the state of another system. Now that you have a grasp of what state and side effects are, you can understand that state and side effects are everywhere in software development. To summarize, when something has only one state, it is essentially stateless. Static, it cannot be interacted with. But when it can be interacted with, it has two or more states and it accepts side effects through which it can be changed. So now that we have sort of like a general idea about what state is, let's look at how state has been implemented in the past. Let's go back 22 years to the year of 1996. In 1996, ID Software released Quake, the first fully 3D first-person shooter game. This was the state of the art at the time and it was pretty awesome. It's funny to compare this to the state of the art of the web in the same year. This is what in the same year the most advanced search engine looked like. It's a far cry from 3D rendered games, and the reason I start here is because I want to give us an idea about how to manage state in a web page. So the way this works is that like any user interaction leads to a full round trip to the server, which served the new state of UI. The browser is just a dumb client. It keeps only like very little states around and like your scroll position, and maybe there's some JavaScript code or to validate your form, and of course there's a cookie that identifies you with the server. And almost all state is stored in the server on a database. And around the turn of the millennium, we got Web 2.0. This was just marketing, but what it came down to is that websites became more and more like actual applications. For example, Gmail in 2005. And interaction now didn't require full-page renders anymore. The feedback was immediate and like local to the user action. For example, you could archive an email without a whole page refreshing. And in order to make this kind of interaction possible, at least some state was also now represented in the browser and not only on the server. And this kind of interaction was also made possible through Ajax, which allows you to send network requests in the background. And libraries like Prototype.js or YUI, MooTools, and some others, and definitely the most popular one, jQuery, popped up. And these libraries made it much easier to work with Ajax and the DOM and other browser APIs. So now that the browser also started representing states, we can start wondering where was this state actually stored in the browser. This is a snippet I found online when I looked for a jQuery shopping cart, and it defines what happens when a user clicks on the Add to Cart button next to a product. And if you look at this code, can you figure out where the state is stored? Of course, there are some states stored in variables, in this case on window. But it was also normal to represent state by updating the DOM to reflect that state. In this case, a new item added to the shopping cart. And the DOM was also used to retrieve data. In this case, the price of an item. And this was not an anomaly or anything. jQuery encouraged storing data inside the DOM, especially with its data API. And this approach encouraged implicit dependencies between the DOM, JavaScript, and CSS. It led to fragile code that was hard to scale and broke easily. People got quite quickly fed up with jQuery spaghetti code, and in 2010 we saw a shift towards sort of model view controller like libraries. Knockout.js, Backbone.js, Ember.js, and Angular.js all saw the light within one single year. And these libraries offered a way to structure your applications through separations of concern. In the case of Backbone.js, a separation of model representing the data and view representing the presentation, the DOM. And although these libraries were a huge improvement and we were able to build web applications that were much larger and more capable, there were still big problems. Most notable is that it was really hard to understand what state your application was in and how it got into that state. State resided in many different places, and side effects triggered in one part of the application would often trigger state changes in another part of the application. And these kind of applications could suffer from nasty bugs that just kept coming back. In 2003, React was introduced by Facebook, and it caused a paradigm shift in how we build web apps. We got a more mathematical approach to UIs based on functional programming rather than object-oriented programming. And the tagline for React could be view as a function of state. And what this means is that when we say that state is just data and we consider HTML as just a presentation of that data, we can say that the view layer is a function of state. And this is what React offers us. And React enables this through three core concepts. It offers a primary building block, the component. And it's the main mode of abstraction you have in React. Components can be composed together into a strict nested tree of components. And second, state flows through these components but only in one direction. This makes it very easy to reason about any component in this tree. You only have to consider the component itself, the data it receives, and its children to understand why the UI looks like it does. And third, React makes sure that the DOM reflects the state of this component hierarchy by employing a virtual DOM and updating it automatically. A component is self-contained, an isolated unit that gives you a very hard constraint. Everything outside the component is noise, everything inside the component is signal. And there are two kinds of components, and the most simple of them is the functional component. The functional component is a pure component that maps props, aka the data provided by the parent component, to HTML. In this case, the component gets a Boolean property fruit, and we return the HTML representation, pear for true and apple for false. This blog post component takes the article property and returns the HTML for that blog post. It also nests another component, meta, which is recursively evaluated to HTML before a blog post can return. And because these are simple, pure transformations from data to HTML, functions is all we need. This is my parent's blog, and it uses the component that you just saw to render out the blog post data. And this is a static component, it just shows data, it has no state. But what if we wanted to be able to have like a preview mode with a show more button? Then before the button is clicked, the blog post component is in the preview state. And when clicked, it's expanded in expanded state and all the paragraphs are just rendered out like this. When we want to work with state, you cannot use functional components. We have to use the second type of component, the ES6 class component. A class can be instantiated and the reference to this instance can be kept in memory. And thus it enables representing state over time. So our component is no longer a function that takes props and what it returns is what is rendered. Instead, it is a class with a render method, which looks very much like the body of the functional component. State is available under this state, and you can change the state by calling this.setState. And there's actually no other way to read and write state. You have to use this API if you want to work with state in React. So in this example, when the user clicks the Show More button, the state is set accordingly. And when the state is updated, React calls the render method again. But now that our component exists over time, different things can happen to it. For example, its parent component can pass in new properties. Lifecycle hooks like component update allow you to handle these kind of situations. In this case, when a new article is shown, when a new article is passed in as data, we want to set the component back to its previous state. And let's make it a little bit more complex by adding a side effect when the component is mounted. We fetch the article data from the backend instead of getting it from the parent. Like before, the parent component might pass in new props like a new ID. And inside component.update, we need to compare the old with the new ID. And in case it's different, we set the component back to the previous state, wipe out the old article data and create a side effect, fetching the data for the new ID. We already start seeing a problem with lifecycle hooks, and this is co-location. Code co-location. We repeat ourselves. Stuff that belongs together like fetching data is spread out over multiple places. You can of course create helper functions, but that doesn't change the nature of how we are supposed to work with state and create side effects inside the lifecycle hooks of a class component. And things get progressively worse the more responsibility the component has. For example, here the component subscribes to a WebSocket backend. Just more duplication through segregation of lifecycle hooks. A while ago, in April actually, Dan Abramov, the creator of Redux and now working for React core team, tweeted this diagram. And it got a lot of retweets and it's quite popular because it's actually a really helpful diagram. So let's look at it in more detail. It shows like how lifecycle hooks are spread out over time and when they fire, in what order and what phases they belong to. It's a really handy diagram. But it also clearly shows how problematic it is to work with class components. We are exposed to intricate details of the inner workings of React. And there's so many to remember, and so easy to get things wrong or simply forget things. And in order to keep code bases sane and be productive as developers, we isolate logic that we want to reuse in other parts of the code. And this is no different for React. When a component has too many responsibilities, we can split it up into multiple components, and this is actually a really great thing. And the most famous separation of concerns that is popularized within the React community is the separation between smart and dumb components. Smart components do side effects and have state, dumb components are just rendering out the presentation. And this is very powerful and it makes it easy to build applications that you can reason about. But it also comes with a downside, and that is wrapper hell. And it doesn't really matter which userland abstraction you use, if it's higher order components or render props, or if you use context, they are all bound to the constraint from React that data flows downwards to children. And the only way to make that work is to nest components. And the React core team has, been the first to admit these things. They have built React hooks to address these issues. And React hooks is currently still a proposal. They have started an RFC, so a request for comments, process to get feedback from the community. And one important thing to note beforehand is that React hooks is purely additional, so no breaking changes. And you can keep doing what you always wanted to, but you can also start using React hooks in a future version of React. And in summary, React hooks essentially gives you two new things. React hooks enables you to do state and side effects inside functional components, which was first exclusively the domain of class components. And React hooks allow you to make the use of state and side effects without having to nest components. So let's look at like two React hooks, use state and use effect. And let's start with use state. It's likely the most simple hook that you will ever use, and it's also likely the first one you will use. It is a named export from React, and it allows you to use state inside a functional component. You call it with the initial value, in this case false, and it returns an array with two elements. And this array, the first item in this array is the current value of the state, so in this case to begin with false. And the second is the function with which you update the state. In this component we show a different fruit depending on the value of the state. We toggle the state between true and false whenever the user clicks the button. And these are just variable names, right? So you don't have to call them state and set state. You can call them whatever, fruit and change mind, for example. You can use useState as many times as you want, and although they are special, you can still treat them like normal functions. In this case, we use two, one for to keep the fruit, and the other one to have a counter to capture how many times we click the button. Let me show you. So here we have the button, you click on it, it changes both states. And the animation just comes from CSS. The second hook you will likely use is useEffect. It is also a named export from React, and it allows you to do side effects. The first argument to useEffect is a function that will be run each time the component renders. This component takes no props, so it only updates when the state is updated. In this component, every time you click on the button, the count state increases with 1 upon each click. And on average, every 10 clicks, fruit changes as well. Because fruit state changes less often than the count state, it makes no sense to trigger the side effect when only the count has changed. We do not always want to trigger side effects on each render. To be able to control this, you provide the second argument to useEffect. This is an array of values, and if any of these values change between renders, React knows to trigger the side effect. Let me show you. So you see when I click, the title doesn't always change. There you go. Sometimes the side effect needs to be cleaned up. For example, when we subscribe to something, we also need to make sure we can unsubscribe, or otherwise we get nasty memory leaks. And the way you do this with useEffect is that you can return the cleanup function from the callback function that you pass into useEffect. And this cleanup function is called whenever React deems it necessary. You cannot specify when this is exactly, but if you're curious, it runs just before the next time useEffect callbacks is called, and also when the component is removed from the UI. But you don't have to call React hooks from the component itself. You can extract the hooks from the component and put them inside a custom function. This function that sits in the middle is called a custom hook. And a custom hook allows you to create reusable state and side effect logic. So in this case, I wanted to make a simple toggle state function. And I consume this custom hook as a normal React hook inside the component. With custom hooks, we can reuse state and side effect logic without having to resort to nesting inside the React tree and passing state to children via props. We can just consume the custom hooks. And a custom hook can return any value you want. In this case, this custom hook returns the current X and Y position of your mouse cursor. But where do these values come from? From state. The initial value is 0 for both. There are setters like setX and setY, but these are only consumed inside the custom hook and they're not exposed. We update the state by subscribing to the mouse move event inside useEffect. And whenever the mouse move event fires, the state is updated. And the component that consumes the custom hook is therefore re-rendered. I find this code very nice to look at. It's easy to read and it hides the complexity of state and side effects inside the custom hook instead of exposing it to the consumer of this hook. And it's obvious to see how much this cleans up our code. Here you see we consume 3 different custom hooks and there's no nesting. Let me show you. I move around, and whenever I click, it changes. And you see that this is quite performant. The position of the button is absolute. So it's being passed new X and Y values continuously. Just before I wrap up, I want to make a quick side note. You might have noticed that React hooks, in the React hooks examples that I've used, I did not do any kind of data fetching. And that's because React has new built-in APIs that allow you to do that in a very nice way. They're called Suspense, React Lazy, and React Cache. And you should definitely use those instead if you want to do data fetching and lazy loading of components. So we only covered 2 React hooks in this short introduction. There are many more. Most noticeable I found use reducer. React has now fully embraced Redux as a pattern to do state. I think that's pretty cool. And to summarize, currently in React you can only use the class component to do state. But in the future React versions you will be able to do state with functions too. And before I end, I would like to show you this animation. It starts with a class component and transitions to a functional component using React hooks. And the colors that you will see show like semantically related code. And you can see easily how the colors at first are really spread out and then how they become more co-located in the functional component. Beautiful. So if there's anything that you want to take away from React hooks, it's these 3 things. React hooks enables you to use state and do side effects inside functional components. And the big benefit is that your code will become more co-located. This leads to better isolation, more readability, and allows your code to be more declarative, so that you can focus less on fine-tuning React and more on creating business value for your company and for yourself. And that's the end. And here are some links that you can look up if you're interested in reading more. Thanks for listening.